Dear students, let us continue our discussion on limits. Let's have a look at some of the standard results. Limit x tends to a, x power n minus a power n divided by x minus a. That's equal to n into a power n minus 1, which you know this formula very well. Then limit x tends to a, x power n minus a power n divided by x power n minus a power n is equal to m by n into a to the power m minus n. In the last class also I had discussed the same formula. Then after this, limit x tends to 0 sin x by x, this is equal to 1. Limit x tends to 0 tan x by x is also equal to 1. Okay. Here we have to ensure that x is in radians. Suppose if x is in degrees, see, if you have limit x tends to 0 sin x degree divided by x degree, that is equal to 1, no problem, if both are in degrees. But when they don't mention the unit, say for example if we have limit x tends to 0 sin x degree divided by x, if they mention like this, its meaning is that this x is in degrees but this x is in radians. In such problems, don't directly write this as 1, this is not equal to 1. Here what we need to do is either convert this x degree into radians or this x radians into write this in terms of degrees. Preferably write x degree in terms of radians. As you know, x degree is equal to pi x by 180 radians. So I will write this as limit x tends to 0 sin of x degree. I am writing x as pi x, x degree as pi x by 180 radians. That unit you need not mention, because for the angle the SI unit of measurement of the angle is radians. So if it is degree, you have to specify that degree. If you don't mention, say for example in this case, I have not written whether x is in radians or degrees. So if I don't write anything, it is to be understood that that angle is in radians. Okay. So in such cases what we do, write x degree as radians. So we get pi x by 180 divided by x. Here we have pi x by 180 in the numerator, so you prefer pi x by 180 in the denominator. So multiply and divide by that, pi x by 180 into pi by 180. I have multiplied and divided by pi by 180. Now as x tends to 0, this will become 1. So the answer is pi divided by 180. Okay. Then limit x tends to 0 sin inverse x by x is also equal to 1. How? If I directly apply the limit, I am getting 0 by 0. Sin inverse 0 is 0 and denominator x, when x approaches 0, denominator is also 0. 0 by 0 is an indeterminate form. If it is an indeterminate form, then what do we do? If it is an indeterminate form, then we will go for, if it is of the form 0 by 0 or infinity by infinity, then we will use L-Hospital's rule. What is L-Hospital's rule? What does it say? It says that whenever the limit is of the form 0 by 0 or infinity by infinity, then you can differentiate it. Differentiate both the numerator as well as denominator separately, not by using quotient rule. Separately you differentiate. Derivative of sin inverse x is 1 by root of 1 minus x square divided by derivative of x, which is 1. Now apply the limit as x tends to 0. If I put x as 0, here we will be left with root 1. Root 1 is 1. So the answer is 1 by 1 is equal to 1. So limit x tends to 0 cos inverse x, sin inverse x by x is equal to 1. Then suppose if I am talking about limit x tends to infinity sin x by x, what happens to this? Limit x tends to infinity sin x by x is equal to 0. Why it is equal to 0? I can split this as limit x tends to infinity 1 by x into limit x tends to infinity sin x. Limit x tends to infinity is, not 0, infinity. See, it's a product of two functions. I mean, I am treating 1 by x as one function and sin x as the other function. Product of two functions. If you have limit x tends to a f of x into g of x, then we can write that as limit x tends to a f of x into limit x tends to a g of x. So I am treating this 1 by x as one function and sin x as the other. Okay. Now I will apply the limit as x tends to infinity. limit extends to infinity, 1 by x will become 0. As the denominator becomes larger and larger, and if the numerator is a constant, when the denominator becomes larger and larger, the value of this fraction goes on decreasing. And by the time this denominator reaches infinity, the value of that fraction reaches 0. I'll explain with the help of the graph. So limit extends to infinity, 1 by x becomes 0, and limit extends to infinity sin x. What happens to sin x? As we know, the graph of sin x, okay, I'll explain both the graph of 1 by x as well as the graph of sin x. And let's see what happens when x tends to infinity. Okay, first let's have a look at the graph of 1 by x. 1 by x. Okay, so the graph looks like this. This is the graph of 1 by x. F of x is equal to 1 by x, or y is equal to 1 by x. As you can observe, at 0 the function is not defined. At 0, 1 by x it is not defined. And if I put x as 1, its value is 1. If I put x as 2, its value will be 1 by 2, half of that. If I put x as 3, it will become 1 by 3. If I put x as 4, it will become 1 by 4. So as x tends to infinity, this graph does not touch x-axis, it is very close to x-axis. So as x tends to infinity, as I increase the value of x, larger the denominator, lesser the value of the fraction. As I increase the denominator, the value of this fraction goes on decreasing. See, if I put x as 2, I am getting 1 by 2. You will see that if I put x as 1, we get 1. You will see that 1 is greater than 1 by 2, right? Then if I put x as 3, then we are getting 1 by 3, which is even lesser than 1 by 2. Then 1 by 4, 1 by 5, 1 by 10, then you imagine 1 by 100, and imagine 1 by 1000, and imagine 1 by 1 lakh. Okay, see, you can see that as the denominator increases, the value of the fraction goes on decreasing, and by the time this x reaches infinity, the value of 1 by x reaches 0. So I can write that limit x tends to infinity, 1 by x is equal to 0. Not only 1 by x, even if it is 1 by x square, 1 by x cube, etc. Any constant divided by x or x square, x cube, etc. All of those as x tends to infinity will tend to 0. Okay, anyway I have drawn this. I will also explain what happens to limit x tends to 0, 1 by x. Okay, so here I will use left hand limit and right hand limit separately. I will find out those two. Left hand limit is limit x tends to 0 minus f of x. That is limit x tends to 0 minus 1 by x. X is approaching 0 from left side. When x approaches 0 from left side, what happens to 1 by x? When x is approaching 0 from left side means x value, let us say, I will write one table, x f of x. X is approaching 0 from left side. I will take initially, okay, I will take x as 1, from left side, minus 1 I will take. When x is minus 1, f of x is equal to 1 by x, that is minus 1. When x is minus 1 by 2, when x is, say, here is 1, I am minus 1, I am bringing x closer and closer to 0 from left side. So when x is minus 1 by 2, what happens to f of x? F of x is 1 by x, which is the reciprocal of x. So this will become minus 2. And when x is minus 1 by 5, okay, this will become minus 5. When x is minus 1 by 10, that means I will take minus 0.1. Then this will be minus 10. And when x is minus 0.01, this will become minus 100. And when x is minus 0.001, this will become minus 1000. As we can observe, x comes closer and closer to 0, the value of 1 by x, the value of that function goes on decreasing. From minus 1, minus 2, minus 5, minus 10, minus 100, minus 1000, etc. It goes on decreasing and it will tend to minus infinity. So as x tends to 0 from left side, 1 by x will tend to minus infinity. Okay, so which means I can write limit x tends to 0 minus 1 by x as minus infinity. Then let us say what happens to right hand limit. Right hand limit means limit extends to 0 plus 1 by x. X is approaching 0 from right side. When x is approaching 0 from right side, okay, I'll write a table for this also. I'll write here. X 1 by x. Okay. So when x is 1, f of x is also 1. I am bringing x closer and closer to 0. So I will take x as 0.5. Then what happens to 0.5? This is nothing but 1 by 2. Then what happens to 1 by x will become 2. If x is 0.1, 1 by x will be 10. If x is 0.01, it will be 100. If x is 0.001, 1 by x will be 1000. So as we can observe, which is evident from this graph also, as x comes closer and closer to 0, from right side, the value of 1 by x goes on increasing. Okay, so value of 1 by x goes on increasing, and by the time it reaches 0, it will tend to plus infinity. So I can write limit extends to 0 plus 1 by x is equal to infinity. Left hand limit is minus infinity, right hand limit is plus infinity. Therefore, this limit does not exist. Okay, limit extends to 0, 1 by x does not exist. However, this limit exists. Limit extends to 0, 1 by x square. This limit exists and it is equal to infinity. Because here x square is there, whether x is approaching 0 from left side or from right side, this will be positive only, it will be increasing, so it will tend to infinity. Then limit extends to infinity, 1 by x, that is equal to 0. As you can say, when x tends to infinity, 1 by x will tend to 0. Okay? Then I was talking about sin x. I was actually talking about limit extends to 0, sin x extends to 0, extends to infinity, sin x by x. Extends to infinity sin x by x, right? So I am writing this as limit extends to infinity 1 by x into limit extends to infinity sin x. Okay. Now already we have seen that this limit will become 0. As extends to infinity, 1 by x will become 0. 0 into this will be equal to 0. See, not necessary. You might think, sir, why do we need now? Why do we need this? Directly we can write 0 into anything is 0. 0 into anything is 0 provided that anything is finite. Right? 0 into 0 is 0, no problem. 0 into any finite quantity is also equal to 0. But 0 into infinity is an indeterminate form. 0 into infinity is not equal to 0. Okay? See, generally we have been told that 0 into anything is equal to 0. But now that you have grown up, you are in the second PUC, you must understand that 0 into anything is equal to 0 provided that anything is finite. Okay? Right. So now we want to know what is the value of this. For that, let me have a look at the graph of sin x. You are very well aware of the graph of sin x. This is the graph of sin x, right? It goes in this way. Here is 0, pi by 2, pi, 2 pi, 3 pi, 4 pi, etc. So you have seen that the graph of sin, its maximum value is 1 and the minimum value is minus 1. So whatever may be the value of x, sin x, it reaches this one here. The whatever may be the value of x, sin x will never go above 1 and it will never come below minus 1. Okay, this graph continues in this way. So even when x tends to infinity, sin x will be something between minus 1 and 1. It will be somewhere between minus 1 and 1. We don't know what is the exact value of limit extends to infinity sin x, but we know that it is something between minus 1 and 1. So I can write like this. This value is 0. This is a finite quantity or a finite value between minus 1 and 1. That we can guarantee. That 0 into a finite quantity between minus 1 and 1, therefore this product will be equal to 0. But if I ask you directly, limit extends to infinity sin x, what is your answer? Your answer is this limit does not exist. Why this limit does not exist? I told you that this is something between minus 1 and 1, some finite number between minus 1 and 1. But between minus 1 and 1, how many numbers are there? There are infinitely many real numbers between minus 1 and 1. Therefore, this limit does not exist, whereas this limit does exist. Please understand this. Here, why I am saying this limit exists? Because here you have 0 into a finite quantity between finite value between minus 1 and 1. Therefore, this product will become 0, so limit exists. Whereas here, we don't know what is the exact value. We only know that it is something between minus 1 and 1. What is its exact value? We don't know. So, here limit does not exist. Whereas here, limit does exist because we know that it is something between minus 1 and plus 1. Okay? Then, similarly, the same rule can be applied for limit extends to infinity cos x by x also. Limit extends to infinity cos x by x is also equal to 0. Okay, next limit extends to 0. This is another formula you need to know. Tan inverse x by x. This is equal to 1. How? If I directly apply the limit, I am going to get tan inverse 0 divided by 0. Tan inverse 0, what is the value of tan inverse 0? 0 divided by 0. 0 by 0, an indeterminate form. So what do? I will go for L-Hospital's rule and differentiate it. Derivative of tan inverse x is 1 by 1 plus x square divided by derivative of x, which is 1. So apply the limit as x tends to 0, we get 1. That's the answer. So remember this as a formula. Limit x tends to 0, tan inverse x by x is equal to 1. Okay, next example. Limit x tends to 0, 1 plus x to the power 1 by x is equal to e. Remember this is a standard result. You have come across this in first place also. Limit x tends to 0, 1 plus x to the power 1 by x is equal to e. Okay. Then limit x tends to 0. See here, one thing you need to remember that here if you have x here in the power that should be the reciprocal of whatever we have here. So 1 plus x you have here, it should be the power should be the reciprocal of this. Then only you can write it as e. Now suppose if you have a problem where you have 1 plus ax to the power 1 by x, then what is its value? Where a is any real number. Then what we do is limit x tends to 0, 1 plus ax here. Here I said we want the reciprocal of this. Here we have ax. So there in the power we want 1 by ax. So what do? I will go for 1 by ax into a. I am multiplying and dividing by a. Now as x approaches 0, 1 plus ax to the power 1 by ax will become e. And there the power is a. So the answer will be e to the power a. Limit x tends to 0, 1 plus x to the power 1 by x is equal to e. Therefore limit x tends to 0, 1 plus ax to the power 1 by x can be written as e to the power a. Okay, next. Say on the same lines we have one more formula, that is limit x tends to infinity, 1 plus 1 by x to the power x is equal to e. Actually, these two results are one and the same. How? I will prove you now. I will make a substitution as let x is equal to 1 by y. Okay? Let x is equal to 1 by y. Then as x tends to 0, y will tend to infinity. Okay? I have to change the limits. Limit, instead of x tends to 0, I can write y tends to infinity. Limit y tends to infinity, 1 plus, in place of x I am writing 1 by y to the power 1 by x. 1 by x will become y. That's equal to e. If this is equal to e, this is also equal to e. Now you observe that this result and this result are one and the same. Limit x tends to infinity, 1 plus 1 by x to the power x. Instead of x, we have y here. That's all. Limit y tends to infinity, 1 plus 1 by y whole power y is equal to e. So in such problems also, you observe that here we have 1 by x and the power is reciprocal. Okay. So if I have something like limit x tends to infinity, 1 plus 3 by x to the power x. Then what do we do? In the power here 3 by x is there, so this power should be x by 3. You multiply and divide by 3. Now as x tends to infinity, 1 plus 3 by x to the power x by 3 will become e, and so the answer will become e cube. Okay, so you have to remember this formula. Limit x tends to infinity, 1 plus 1 by x whole power x is equal to e, or another version of the same formula, limit x tends to 0, 1 plus x to the power 1 by x is equal to e. Okay, next limit x tends to 0, a power x minus 1 divided by x, this is equal to log a to the base e. This formula you remember. I think these two formula, limit x tends to 0, e power x minus 1 by x, this is equal to 1. You have already come across these two formula, you must remember this. Okay. If you can remember, well and good. If you cannot remember, I give you the proof how I got that formula, so then you can remember it. Okay. See here, we have limit x tends to 0, a power x minus 1 by x. If I directly apply the limit, I am going to get a power 0. What is the value of a power 0? 1. 1 minus 1, 0. Numerator is 0. Denominator, as x tends to 0, it will be 0. So this is of the form 0 by 0. If it is of the form 0 by 0, then we can use L-Hospital's rule. So differentiate this. Limit x tends to 0, derivative of a power x. That you should know. If you don't know that also, I cannot help you. Derivative of a power x is a power x into log a divided by derivative of x, which is 1. Now apply the limit as x tends to 0. So when I apply the limit as x tends to 0, a power 0, which is 1, into log a base. If I don't write any base, you must understand that the base is e. So log a to the base e. So here, what's the difference between these two? In place of a, we have e here. So replace this value will be equal to log e to the base e. Logarithm of any number to the same base is equal to 1. That you know. Or if you want to use L-Hospital's rule, then also you are allowed to do it. You can do it. In the derivative of e power x is e power x. Derivative 1 is 0. Derivative 1. Apply the limit e power 0 is equal to 1. In this way you can do it. Okay, so remember these two, and from here you will get another formula, that is limit x tends to 0, a power x minus 1 by b power x minus 1 is equal to log e to the base b. This you can directly remember, or else here also you can use L-Hospital's rule, because if I directly apply the limit, I am getting a power 0 here. A power 0 is 1, 1 minus 1, numerator is 0, denominator b power 0 is 1, 1 minus 1, 0, 0 by 0, an indeterminate form. So I use L-Hospital's rule. If I use L-Hospital's rule, derivative of a power x is a power x into log a, derivative of b power x minus 1, that is b power x into log b. Now if I apply the limit as x tends to 0, a power 0 is 1, this is a constant, so 1 into log a, numerator is log a, denominator b power 0, which is also 1, into log b. So we get log a divided by log b. Don't cancel this log, not allowed. Log a divided by log b can be written as log a to the base b by using change of base rule. Okay, in this way you can remember this formula. Then, what next? Suppose if I have this limit x tends to 0, mod x by x, this limit does not exist. Why it does not exist? Because I will try to find a left hand limit and right hand limit separately. Left hand limit is equal to limit x tends to 0 minus mod x by x. X tends to 0 minus means x is approaching 0 from left side, which means x is negative. Whenever x is negative, mod x is defined as minus x. So limit x tends to 0 minus x by x. That's equal to limit x tends to 0 minus 1, which is equal to minus 1. Left hand limit is equal to minus 1. Now I want right hand limit. That's equal to, see, I have, before applying the limit, I have cancelled that x. So minus 1 is there. Limit x tends to 0 minus 1 is equal to minus 1. Now, right hand limit. Limit x tends to 0 plus f of x. F of x is mod x by x. That's equal to limit x tends to 0. X is approaching 0 from right side. X is approaching 0 from right side means x is positive. X is greater than 0. So x is positive. Whenever x is positive, mod x is defined as plus x. So limit x tends to 0, x by x is equal to limit x tends to 0, 1, which is equal to 1. Left hand limit is minus 1, right hand limit is plus 1. They are not equal. Therefore, the limit does not exist. Okay? Then, on the same lines, I can write limit x tends to 0 mod x minus a divided by x minus a does not exist. So here also the same thing will happen. The left hand limit will be equal to minus 1 and right hand limit is plus 1. Therefore, limit does not exist. Okay. Then, now infinite limits. Now let f of x and g of x be two polynomials of certain degree. Okay. F and g are two polynomial functions. Then let us say what happens to limit x tends to infinity f of x divided by g of x. What happens here in different cases that we should observe. Okay, different cases in the sense the degree of f of x and the degree of g of x. I'll explain this first with the example. And after that, I will give you a formula. Now, let me take this. Limit x tends to infinity, x square plus 3x plus 7 divided by x cube plus 5x square plus 3x plus 2. Okay, I want to apply the limit as x tends to infinity. If I directly apply the limit, I am getting infinity plus 7, which is infinity only. Denominator is also infinity. We can go for L-Hospital's rule, or else the other thing what we can do is, in the numerator, I will take x square as a common factor. If I take x square as common, what will remain here? 1 will remain, plus here 3 by x will remain, here 7 by x square will remain. In the denominator, I will take x cube as common. If I take x cube as common, then what will remain here? 1 plus 5 by x plus 3 by x square plus 2 by x cube. Okay? From 5x square, if I take x cube out, 5 by x will remain. Or if you have any confusion, bring this x cube inside. Just check whether you are getting back to this or not. If yes, then you are right. X cube plus x cube into 5 by x will give you 5x square. X cube into 3 by x square will give you 3x. X cube into 2 by x cube, whether x cube gets cancelled, we will get back to it. Okay. Now, as x tends to infinity, 3 by x will tend to 0. As I already told you, when x tends to infinity, 1 by x, 1 by x square, 1 by x cube, etc. Not just 1 in the numerator. In numerator, let it be any constant. Denominator, if it is x square, x cube, etc. anything. Then as x tends to infinity, they all become 0. So as x tends to infinity, this will be 0, this will be 0, this will be, all these will become zeros. And here what happens? X square gets cancelled. One of those x will remain. So you are having limit x tends to infinity 1 by x here into these are all 0, 1 by 1. So as x tends to infinity, this 1 by x will also become 0. Right? Therefore, the value of this limit is equal to 0. Okay? So from this what we observe is that if the degree of the denominator is larger, both are polynomials, and we have a limit extends to infinity. F of x by g of x, both f and g are polynomials, and degree of g of x is greater than the degree of f of x. That is, degree of the denominator is larger than the degree of the numerator. Observe here, here it is 3, here it is 2. Degree of the numerator is lesser than the degree of the denominator. Denominator has a larger degree. Then the value of that limit is equal to 0. Remember this as a formula. Okay? Now, I will consider the other case. I will say degree of the numerator is larger. Limit extends to infinity. Let me take 2x cube plus 3x square plus 5x minus 4 divided by x square plus 2x minus plus 3. Like this. Now, observe that numerator has a larger degree. Okay. So here I will take x cube as common in the numerator. So we will have x cube into 2 plus 3 by x plus 5 by x square minus 4 by x cube divided by, here I take x square as common, 1 plus 2 by x plus 3 by x square. Okay? So this x square gets cancelled. You are left with the x here into, what is happening here? 2 plus 3 by x plus 5 by x square minus 4 by x cube divided by 1 plus 2 by x plus 3 by x square. As x tends to infinity, this 3 by x will become 0, 5 by x square will become 0, minus 4 by x cube, 2 by x, 3 by x square, all of those will become zeros. So here you have 2, here you have 1, and what happens to this x? That will tend to infinity. So then what happens? Infinity into 2, what do you get? You don't get 2 infinity, you will get infinity. Infinity is such a huge number that if I multiply by anything or add anything, it will still be infinity. So this value will be equal to infinity. Okay. So from this what we observe? That is, if the degree of the numerator is greater than the degree of the numerator is greater than the degree of the denominator, then the value of this limit will be equal to plus infinity. Plus infinity provided the coefficient of the highest power of x is positive. Say I will give you another example here. Instead of 2x cube, suppose if I have minus 2x, let us say minus 2x, then this is what you will have. Right? Then after cancelling all those, you will have minus 2x by 1. That is, when x tends to infinity, now it will tend to minus infinity. This value will become minus infinity. So from this, we observe that when the degree of the numerator is greater than the degree of the denominator, then the value of that limit is either plus infinity or minus infinity, depending on whether the coefficient of highest power of x in the numerator is positive or negative. If it is positive, it will tend to plus infinity. If it is negative, then it will tend to minus infinity. That you have to remember. Okay. So now I will consider one more case where, what is the next case? See, in the first case I have considered degree of the denominator as greater. In the second case I have considered the degree of the numerator as greater. So in the third case, what do? Yes, you are right. We will consider both polynomials of the same degree. So let me take 2x square plus 5x minus 3 divided by 3x square plus 2x. Okay? Even if I write this much also enough, or if you want, you can have constant also. Okay. So now we observe that we have limit extends to infinity. F is a polynomial and g is another polynomial. Both polynomials are of the same degree. Now what happens? Let us check. So limit extends to infinity. In the numerator, I will take x square as a common factor. Okay? X square as common. Then what will remain? 2 plus 5 by x minus 3 by x square divided by, here x square will be common, 3 plus 2 by x plus 1 by x square. This x square gets cancelled. As x tends to infinity, 5 by x becomes 0, minus 3 by x square is 0, 2 by x becomes 0, 1 by x square becomes 0. All these become 0. Then what will remain in the numerator? 2 plus 0 minus 0, that is 2. Denominator 3 plus 0 plus 0, that is 3. So answer is 2 by 3. Okay. Now without doing all these things, directly you can write 2 by 3. That's all. Okay. That 2 by 3 should be, that answer should be, when the polynomials are of same degree, then the answer is the coefficient of highest power of x in the numerator divided by the coefficient of highest power of x in the denominator. Okay? Now, so by what we have learned so far, let me write a formula for this. When you have limit extends to infinity, f of x and g of x. I will say degree of f of x is m. Degree of f of x is m and degree of g of x is n. Let m be the degree of f of x and n be the degree of g of x. Then limit extends to infinity f of x by g of x. F and g are two polynomials of degree m and n respectively. Now I will explore all possible cases. It is equal to 0. This value will be equal to 0 if, when it will be 0? When the denominator has a larger power. That is, when m is less than n. Okay? If m is less than n, if the denominator is larger, then the value of this will be equal to 0. Then, infinity, if m is greater than n, that is, degree of the numerator is greater than n, greater than the degree of the denominator, and coefficient of x power m is positive. Coefficient of x power m must be positive, because if coefficient of x power m is negative, then answer will be minus. Okay. So minus infinity if m is greater than n, that is, degree of the numerator is greater than the degree of the denominator, and coefficient of highest power of x, the degree is m I have taken, so the highest power of x must be m. X power m is, coefficient of x power m is negative, and it is, see, when they are equal, what happens? When they are equal, it will be, when they are equal means both are of the same degree, so m is equal to n, then coefficient of x power m in f of x in the numerator divided by coefficient of x power n in g of x if m is equal to n. You remember this formula. So if you can remember this formula, then directly for any problem of this kind, immediately just by looking at that problem, you can directly write the answer. Okay? Did you understand? If the degree of the denominator is larger, then the value will be 0. If the degree of the numerator is larger, then the answer is either plus infinity or minus infinity, depending on the coefficient. And if they have equal powers, okay, if the degree of the numerator is same as the degree of the denominator, then the answer is coefficient of highest power of x in the numerator divided by the coefficient of highest power of x in the denominator. Okay. Next, limit n tends to infinity x to the power n. What happens to this? Okay. Now two cases will arise, whether that x is less than 1 or greater than. Let us say x is less than 1. Okay. Here n, the power is tending to infinity, that x is less than 1 I will take. For example, if I take x as 1 by 2. Okay. I would like to find the value of this. Limit n tends to infinity, 1 by 2 whole power n. Okay. N is approaching, that power is increasing, then what will happen to this? As the power increases, you just see what happens to the value of that fraction, whether it increases or decreases. Suppose if I take n as 1, then you have 1 by 2. Put n as 2, then you have 1 by 4. 1 by 2 whole square, that is 1 by 4. Observe that value is decreasing. Then put n is equal to 3, you have 1 by 8. Put n is equal to 10, you have 1 by 1024. Okay. So as we increase, see just for n equal to 10 only we are getting 1 by 1000, 1 by 1024. When you think of infinity, as n tends to infinity, the value of this fraction 1 by 2 whole power n, it goes on decreasing, right? And by the time this n reaches infinity, see when the power is 10 we have this 1 by 1024. When the power is 100, I am talking about 1 by 2 to the power 100. You can imagine how bigger the number 2 power 100 is. Okay, not just that, you can even think of 1 by 2 power. Okay, look at this, like this, and infinity is even greater than this. So you will see that when the denominator is such a huge number, then this is negligible. So by the time this n reaches infinity, this 1 by 2 whole power n will tend to 0. Okay, so whenever the fraction is less than 1, the value will be equal to 0. If the fraction is greater than 1, on the other hand, I will take this. If n tends to infinity instead of 2 power n, instead of 1 by 2 whole power n, now I take 2 power n. Now I increase the power of this 2 power n. So I am getting 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 100, 2 power 1000, 2 power 1 lakh, 2 power 7 crores, etc. So when you do that, you see what happens. The value of this fraction, now I say this fraction because I can write that as 2 by 1 whole power n, right? So as this fraction, as the power increases, the value of this fraction goes on increasing, and by the time the fraction reaches infinity, this value, by the time the power reaches infinity, the value of this fraction will also reach infinity. Okay. So from this, what we can conclude? Limit n tends to infinity, x power n is equal to 0 if x is less than 1, or specifically I will write mod x less than 1. Then limit n tends to infinity, x power n is equal to infinity if mod x is greater than 1. But if x is equal to 1, then what happens? Suppose if I have limit n tends to infinity 1 to the power n, then what happens? You might think, sir, 1 power n, 1 power any number is always equal to 1, so this value will be equal to 1. It is not true. This is of the form 1 power infinity. 1 power infinity is not equal to 1. Now again, you have been told from your lower classes that 1 power anything is equal to 1. Okay, 1 power anything is equal to 1 provided that anything is finite. In this case, we have 1 power infinity. 1 power infinity is an indeterminate form. Okay, I'll give you that formula also. I'll give you one formula. Proof is not necessary for you. If whenever you are applying a limit, suppose if you have, let us say, limit extends to infinity, f of x to the power g of x. If I have this, then what we will do? We will directly try to apply the limit directly. Let us say that this base, this will become as extends to infinity. If this is 1 and if this is infinity. Okay, not just for infinity, you can apply it for any real number or any number, even if it is infinity also. Limit extends to f of x power g of x. If you are directly applying the limit, if you are getting 1 power infinity, when we directly apply the limit, if we are getting 1 power infinity, then what we should do is, we can use this formula. Limit extends to a f of x to the power g of x is equal to e to the power limit extends to a f of x, sorry, e power limit extends to a g of x into f of x minus 1. This one formula. Limit extends to a f of x to the power g of x can be written as e to the power limit extends to a g of x into f of x minus 1. I will discuss about this further when we come across such problem. Again, there I will explain this formula. You just need to remember this. Well, if you have limit extends to a f of x to the power g of x, and when we apply the limit, if it is of the form of 1 power infinity, then limit extends to a f of x to the power g of x can be written as e to the power limit extends to a g of x into f of x minus 1. Okay, students, this much of synopsis is enough as of now. So with this I will stop today's class. In the next class I will discuss problems. Still some more concepts, especially on continuity I have to discuss, and still few more shortcuts I have to discuss. Those things I will discuss while solving those problems. Okay, in the next class we will start with the problems. Okay, thank you.